Well, welcome. You made it to the end of the conference. Relax, there's nothing technical going on here. All of the slides are very, very business oriented, and hopefully you enjoy it. So, I am a database consultant based out of New York City here. I have been working with a variety of industries as a consultant, and I've seen a lot of situations where applications have grown over time and the databases attached to them have come along with them with a fair amount of benign neglect in the way. In all of those experiences, I've noticed that software tends to have phases to it that sort of map to the evolution of the Earth. So in the beginning, you had the 7 angel investors, and they created a set of developers, and they set about making the big product. Those developers set to work and worked in a furious pace that I call the late heavy bombardment. This was a fast-paced environment. The requirements, if ever written down, were changed very, very often, and people often would not remember them from one day to the next. If you are doing archaeological research on this period of development, you will notice things like commit messages that are less than 3 words, code comments that reflect the current state of caffeination or mental health of the developer writing it, and of course, commits that are spaced less than 10 minutes apart, often undoing the very thing that was done before. Things get a little better as the development continues, and they settle down, the commits get a little further apart, and people seem to begin to relax, and they enjoy being at the startup. However, the business people are still working, and they are coming up with new ideas of how to combine what they've built into new and interesting ways, and there are new partnerships that can be formed, and at the same time, there's other partnerships that can be formed out there that could eat you. So the urge to keep evolving is a strong one. Key features for this when you're looking through your repository are the features appear very bolted on, no real cohesion with the initial core product. And then vague comments that say that we had wasted a lot of time a few months ago, that we could have been better prepared for this. Eventually, your product gets customers, and you have grown up into a real business. This is when scaling issues start to arise. Often, the data volume is not what you expected, and your database is not sized correctly, nor is your application server sized correctly. But also, the data you're getting doesn't meet the expectations you had, because everything you had been doing up to this point was grading your own homework. And so now the infinite variety of customers you can have and data sources you want to pull, and the terrible quality of the data that comes in from them starts to haunt you. However, you are a viable business now, so you need to accept this data immediately, and this leads to some very rushed design decisions, often where the quality of the data in the database suffers greatly. The biggest hallmark of this period in GitHub is a 7-line bash script that very few people understand, no one dares touch, and is absolutely vital to the daily ETL. Well, this can't go on forever. People get angry with the situation. They get tired of constantly patching things, putting baler twine around their applications to get them to make it through another week. And that's not what these developers signed up for. They were here to do greenfield development and make a great product. They didn't want to maintain the thing. So often what they will do is say, well, we need more developers because I don't want to do this. And so they hire more developers. The problem there is that their idea of a good developer is themselves. So they hire somebody with largely the same outlook as themselves, and they don't want to do that job either. And then the original developers start to leave the company whether or not new people were hired on. When the trilobites leave your system, you know you're in trouble. The next phase, those new developers and those survivors attempt to understand the existing system as it was written. But the documentation is very poor if it exists at all. The authors are either totally gone or they're so mentally checked out that they're not useful for understanding these systems, and they seem to resent being asked. Frustration mounts again. Yes, Deb?
These new developers, do they have those cool red flower pot hats?
No, I don't believe so. That's evolution in reverse. So de-evolution, yes. Frustration mounts among them, and then they decide, hey, I'm a great greenfield developer. It would be so much easier if I just rewrote this thing now that we know the real requirements. But not the database. We need the database. That's persistent. So that'll stay the same. But the whole app, we're going to just rewrite it. So now we reach the point in Earth's evolution where we have an actual green field to develop on. And the new developers have come in and they've rewritten the app. But it only does about 80% of what the other app did, and that other 20% is critical. And that last 20% is really hard to understand, either because the specs are incomplete or it was innately a hard problem and what you had there is not actually solving it, it's not apparent the way that it isn't. Either way, it's very hard to do it right. At this point, those developers have options. They can invest in hard work, put their head down, and really understand that last 20%. They can go into management and hire developers to take care of that last 20%, or they can make a slide deck and a blog post and get a new job. Whatever they do, now we have two systems that need supporting, and those two systems both interact with this database, sometimes in overlapping and contradictory ways. Neither system is particularly well documented because the second group of developers just assumed that this thing was going to be easy. And now both of them have maintenance issues. So we have just compounded the problem. Some of those developers begin to leave. They can invest hard work in understanding the two applications that are there. They can scrap both of them and start over. Or they can start listening to application vendors who say we can solve all of this with a wonderful no-code solution. Or they can do what many have done before, update their LinkedIn. The vendor solution comes in, and guess what? It does 80% of what is needed, but not the 80% that replaces either of the first two systems. So now those must still be maintained with really no one who has any original experience with them, and you have three problems. Moreover, you used to have everything where you had an application server inside your local network and another application server inside the local network talking to the database in your local network. But this vendor solution is often in some other place, so you have interconnecting issues there, and there tends to be some data exchange that needs to happen the way the vendor needs it to happen. So you find yourself, rather than saying, oh, connect to our database and get this information, you find yourself writing some sort of a data extract, which is then uploaded to them. And this just further muddies, like, what data are they actually going after? The last iteration of this that often happens is the vendor solution with hosting. Move it to the cloud. Again, it will solve 80% of the problems, and now you have 4 problems. That leads us to the Cenozoic era, otherwise known as your first day on the job. Okay. The first thing to recognize is that your database is more than just the server in the rack. There, for one thing, there may not be just one database on there. Quite often, developers in a hurry to create a separate database isolated from the chaos that was the first database will create a second instance on the same server, and it has its own connections, and however, it is inextricably tied to the hardware of the first server. That's one thing to check for. Those things aren't always documented. Your backups are a part of this, your input sources, the customers, and your service level agreements, and I'll be going into details on those. Step 0, every site reliability person here will start off with the backups. Do you have them? Confirm that you have them. This is now your responsibility. Find out where they are. Find out how far back they go, because the disaster of data loss may have already happened. You don't know it. And then the other part of this is, if you can't restore the backup, then you don't have a backup. So you need to ask, when was the last time this was tested? And whatever their answer is can we do another one of them tomorrow? We need to make sure that you have seen this go. You know how long the restore takes. You know when somebody asks, how long are we down for? You have a ballpark answer. Until you have one restore done, you don't know. SLAs, service level agreements. This is your contract, be it written or verbal, with some other customer or their contract with you, that this data will be available at these times with this level of accuracy. Now, most of these SLAs that you have will be unwritten. Most people will say, well, this data needs to be available 24/7. That can actually be right, and you're going to have a very bad time if it is. But you need to talk to your consumers, your customers, and the people who are feeding you data, and figure out what their needs actually are, and then look for the gaps, because somewhere you've not colored in one part of the calendar, and that's your maintenance window. That's your wiggle room. Survey all of the applications that talk to this database and find out what happens if the database is offline. If it's not there, what do you show? Do you 404? Do you just keep hammering it, trying to reconnect? Whatever. The applications need to have some concept that there is a maintenance period, and they need to have a thing they want to do during that period so that it doesn't look like the whole app has crashed. If you get pushback on this, remind them that not all maintenance is planned. The database could go down. The server could have a disk failure. There could be a networking issue. What do they want their application to look like when it can't serve up data? But with that, you want to add in the nuance that there are different sorts of offline. There is physical wear down. This database is not serving up queries of any kind. There is also this table or this set of tables is currently locked in an operation and you can't query it, but the rest of the database is fine. Find out what those applications need in terms of tables, and find out where your groups of tables are that you could periodically, shut off those tables to access for a brief period of time while you do some maintenance. Essentially the way that some fish switch which side of their brain is awake so that they're always swimming. Have this plan for every application. This part is just an absolute grind, but it must be done. You must document your database. This becomes especially important if your company is acquired, and especially if it is acquired by a large company in a regulated industry, like a bank or a hospital or something like that. First of all, ask, is there a data dictionary out there? Spoiler alert, there isn't. You're going to have to create one. You're going to have to create one for your tables, your columns, your constraints, and your indexes. And you're going to have to decide if you want to have an internal metadata store or an external one. The internal one is probably where people here are going to be a little more comfortable. There is, of course, the comment on. You can comment on table command, you can comment on column, and you can add a multi-line descriptor to any object or attribute of an object inside a Postgres database. The really cool thing is that these things are all stored in a table called PGDescription. And you can figure out which columns, which tables, which objects do not have one by doing a left outer join against your PG class and PG attribute tables and PGDescription. And from here, you can further write a script that creates a JIRA ticket to tell somebody to document this table. This is great stuff, and the great part about it is when you've added these comments to your database, you know that they're there. They have the exact same retention as your database. They get backed up right along with it. But also, the downside is that they're perfect for you and nobody else. Anybody who does not regularly access this database will never know they exist. So you're probably going to need to export them to some external source. That is probably some sort of a cloud-based spreadsheet or a series of documents. And these have good visibility, and the people, the regulators, the lawyers that need to see this stuff and need to audit this stuff will be very, very comfortable there. And it also allows you to have a much more rich set of descriptions, because the text you have inside Postgres and PGDescription is just an unstructured string. Sure, you could make a JSON that puts types in it and stuff, that you could do that, but generally, like, having a more breakdown about, like, is this column personally identifiable? Is this column visible to this group of people? Those can be just different columns in your spreadsheet, and that's probably where you're going to end up getting a lot of this work done. So you start off with your tables. The first question is, why does this table exist? Does anybody use it? How do you know if anybody uses it? Well, how old is the data in it? Inspect it. There's a lot of abandoned tables in databases, and the fastest table to document is the one you can drop. So if you don't need it, find that out quickly and set it aside, because you're going to be able to hopefully export the data in it and throw that in a file store somewhere just for safekeeping, but get it offline, get it out of taking up valuable vacuum time and things like that. So find out what apps use this table. Find out where its input data comes from. And find out where it's going. Then also find out who has the ability to see that table. Those are two different things, the people who need to and the people who can. There's a gap there. Ask why that gap exists and if you can close it. Those tables have columns. Go through those columns and look, is this column populated? If it has no data in it, you may not need it. It could have been something that somebody added on a lark, and then the data that they were hoping to put in there never came through, or they discovered that there was a better type for it, and maybe their tooling didn't allow them to delete the column. That's especially true in things like MySQL, which require a table rewrite for stuff like this. So you will see like these vestigial columns in your table, but don't make the next person wonder. Document that it is unused. That information alone is helpful. For what's in there, is it named correctly? Application programmers don't think about the database very closely, and some of the names they choose either weren't good to start, or the purpose of the table has evolved since they initially created it, and maybe there's a better name for this. Even if you can't change it now, document that it would be better named as something else, so that all of that hard work and thinking isn't lost. What does a null value mean for that column? Are there any? If they're not allowed, no problem. But if there are, well, what does that mean in terms of this? Just expressing that can be helpful to somebody later on who is looking at this table fresh. Can you limit the valid values in a column? You know, if there's one thing that is like the age of a building or something like that, well, those numbers in the US don't need to go over 1,000 for the most part. So with that, does the data in there meet your imagined restrictions? And if not, well, you have a data cleansing problem coming up. And even if you can't fix it now, document that you need to. And then maybe you can start searching PD's description later for like to-do remarks. Is it personally identifiable? This is the absolute bugbear of databases now, because startups really don't think about privacy issues. They're moving too fast. And they don't have an understanding of how insidious privacy concerns are. Case in point, I was doing an analysis of a data set from a company that they had been acquired by a bank. And they thought they had identified all of the personally identifiable information. The problem is that they had some JSON fields and some image files. Now, it turns out that the JSON field was actually the HTML response that was gotten back from a search for a particular thing for that customer. And it included their name right in the text. Likewise, there were screenshots. Want to guess what was on those screenshots? Their name and address. Yeah, it really is nasty, and the liability issues are significant, and you didn't create the problem, but it's going to fall on you. So get that documented now and start addressing it. When you come across time zone, timestamp columns, ask, is this time zone aware? You don't really need to ask if the app was developed in Django or Ruby on Rails, because the answer is no. Are there time zones in this table that imply some sort of a range? Now, Postgres has range types. That's wonderful. Nobody out there uses them, and certainly not any ORM that's trying to make you database independent. So you're going to have to spot these ranges on your own. And then look at them and ask things like, well, what would a collision or an overlap mean in this context? Is that allowable or is that bad? And do we have any of those? That's a data quality issue you're going to have to address somewhere down the line. The other thing to look for in these cases is that often developers will have inserted magic values into their timestamps rather than using null. And so they decide like when forever is, when never is, always, things like that. The year 9,999 is pretty common. The year 3000 is pretty common. The year 1900 for the beginning of time is perhaps a bit short-sighted, but has been used as well. Look for these, and obviously you're stuck with it now because it's hard-coded into something and somebody's running a report that has these baked in. But get these magic values defined, and you're going to start to see them reused throughout the company. And look for when they're being used consistently or not. The last thing to ask about a timestamp is the time component meaningful here? Should this have been a date column? Which brings us to date columns. When is this date? Where is this date? Is it Tokyo? Is it New York? Is it London? Is this date meaningful in a context of some time zone that you must infer from the customer? Important things that reverse it, where now it makes sense for that date to be a timestamp. Likewise, you have the beginning and end implied ranges, although now you're dealing with distinct values rather than continuous values. So having two dates that are adjacent is okay. However, if the logic of your application thinks about the last date as being exclusive rather than inclusive, then you actually want the date ranges to meet on a particular day, because this one means everything up to, you know, July 31st, and this one means July 31st and on. The number-like columns are a little easier, but there you just kind of have to look at like precision and things like that. If you're reading in sensor data, well, what sort of precision do those sensors allow for? It may be to like 3 significant figures, but your database is storing 5. Somebody is going to assume that if you have 5 significant figures in your data, then those are actually accurate, which is not necessarily true. So you want to be careful that your database isn't, there's a balance here between being forward-thinking if we think we're going to get better sensors, and over-promising and enabling your people to make the wrong decisions based on the data that they have at hand, or to infer a level of accuracy that isn't there. Another thing to look for is just check your integer columns for negative values and decide, like, what does that mean from a business sense? That's negative values are a lot of times the place where people store magical invalids and error codes and things like that. Your JSON columns. Well, ever since JSON has been added in, every application developer out there is like, great, I don't have to structure my data, I can just throw it in here. And then 30 code commits later and 100 million rows in the table, it's hard to restructure it. Look at what's in them, look at the level of keys that are in the JSON columns across the whole table. You can sample for this, but I mean, ultimately a rigorous check of every row is probably in order. And then with those, see, well, how common are these things? Is this JSON here just for some sort of a regulatory proof that we hit this particular web request and this was the response we got back, so we're storing it literally? Well, that's okay. That is a good use of JSON. But when it's just a grab bag of attributes that are controlled by us, then it's not. And you can do migrations and turn those into regular columns. That might be a lot of work. In the meantime, you can use like a generated always construct, add a new column that extracts that value out. That allows the developer to go on with their sloppy ways, and you get a proper column. And hopefully down the line, you can make the smaller step of like, now that you've gotten reporting used to seeing this as its own column, now get the input straightened out. Views. They're not so often created, especially not in your Django and Ruby environments and your nodes and things like that. But they do occasionally come up. And then you have to wonder what caused an application developer to sully themselves going into the database to create this thing. Why did it get created? What thing is it simplifying for someone? Once you figured out that rule, did they give it a good name? Did they give it a name that is going to conflict with future development? Is anybody using this thing? If not, it can go away and it can be designed better another day. The best thing for views is as a permission barrier, where you would want to prevent people from seeing certain columns in certain tables, or you would want to give people a read-only access to certain tables, and then obviously like flattening out a big join situation. These are all good reasons to have views, and you shouldn't dismiss those out of hand, but understand why these views were created, and this is your chance to review whether that was a good call or not. With views comes materialized views. Figure out who is this helping, figure out how often it is refreshed, figure out how often that those consumers think it is refreshed, and then ask them, so this data is refreshed at midnight, but new reservations come in throughout the day. Is that okay? You know that, right? That you can't rely on this to be up to the minute. Are you making decisions on this that understand that that data is this level of stale? And that becomes part of your SLAs, and develop that communication with the application developers and the reporting consumers. While you're there, ask yourself, should this have just been a view? Was this materialized because the query that generated it was very, very expensive and has since been tuned, indexed, maybe things got partitioned or something? Can we get away with just having this as a view? The beauty of that is the data is now totally up to date and you never have to worry about staleness. Likewise, refreshing materialized views refreshes the whole view. It's likely that most of the data that went into it was fairly static from one day to the next, and it may make sense to instead have a table and have an ETL to that, and you refresh that, but now you're only modifying 10% of the rows in the table or even less each time, and then you can deliver that on a much more configurable basis, where say all of a sudden you're delivering this stuff every 6 hours instead of every day, or you're delivering it every hour even. Uniqueness. Again, I'm of course trashing the ORMs because they write bad SQL faster than I can tune it. Not all uniqueness is defined. Some of it is just kind of there. The ORMs will always make a primary key on a synthetic integer, and then there may have been some other uniqueness, and maybe they caught it and maybe they didn't. You can have a table of user ID's last login, and obviously there's a uniqueness on the user ID there, but it may not be enforced. In situations like that, you want to work with them to say, hey, can we get this into your migrations to actually make this unique as soon as possible? One trick I have seen in situations like this is that often you need things to be unique right now. You want the reporting code to be able to rely on it being unique. So the trick I've found is to create a unique partial index that utilizes a created timestamp. And you start it off, you create that index with a timestamp floor, so the created timestamp is, say, greater than a date that happens to be 3 days from now. Well, time will march on, and suddenly all rows that come in will be subject to this. The great part about it is that your non-unique data is still there and untouched, but your new data will follow the unique regimen. And then when you have time, you can clean up last April's data, and then you can move the uniqueness constraint back a month, creating a new unique index. And then you can handle March, create another one and move it back, and slowly clean up this table in a way that's is entirely transparent to your app. Your constraints. Obviously, referential integrity is one sort of constraint, but there's also check constraints, exclusion constraints. With each of these, one, be thankful that they're there at all. Two, start to look at, is this constraint too narrow? Should we have tightened it up a bit? If these are calculated ages of dogs, well, should it go over 50? Is the constraint too broad? That's actually a better example of broad. And then, is this constraint one that is temporary? Like I said with the partial index, that is not a permanent solution. You don't want to keep that partial index around forever. You want to use it to bridge to get over into the data model that you want. Your indexes. A little knowledge is a dangerous thing. And many application developers, when they hear that indexes make queries go fast, will index absolutely everything. Because they don't know what this app is going to be used for, so they want to be ready for it. And they've also heard, quite rightly, that adding indexes later leads to a table lock, which leads to an outage, which leads to them getting yelled at. So they don't want to get into that. They just index everything from the start. Of course, they index each column individually, which totally misses the possibility that there was composite indexing that needed to happen, and that was the real solution. But you know, you tune the tables you have, not the tables you want. When you get into this database, just do a create table, my index usage, and then a date stamp, you know, like 2021, you know, 08, 30, whatever. And then a week later, a month later, do that again, and then start comparing those two head to head. I say do it this way because there is a way to zero out the index stuff, but that destroys information. I don't give up on that, because when you do that, you don't know, is this table, is this index, does it show zero usage because it hasn't been used ever, or hasn't been used since I last zeroed it out? So don't reset the odometer on index usage. Compare the snapshots, let the stats grow over time. On top of that, that gives you 2 data points. You can start to see which indexes are used more than others. You know, and you can start to plot a graph of these things. Obviously, getting rid of indexes that are unused speeds up your updates. It also helps define, when people look at this table, they start to see what the usage patterns are based on the kind of indexes that are on it. So if the indexes that are there are proven useful, that is information that somebody can later use. The next thing is that re-indexing compacts, especially B-tree indexes, and makes them more efficient, because over time bloat does build up in indexes, and it's harder to get rid of that than it is on tables. The problem with this is that re-index locked the table while you did this, and it did that until version 12? Okay, I think 12. Now it's possible to re-index concurrently. Prior to this, what you would do as a trick was to create an index concurrently that happened to have the exact same parameters as an index you were trying to re-index. When that was finished, you would drop the old bloaty one and then rename it. And that would match up with whatever the ORM thought the name of the index ought to be. That wasn't possible for primary keys, especially primary keys for a table that is in referential integrity. You just can't swap them out like that. With reindex concurrently, you can do that. You just say the table you want to reindex, and you let it run. Now, obviously, there's some like transactional liabilities to doing things concurrently. There's a possibility that it won't complete and you'll have to try again later, but it's a whole lot better than it used to be. Are your foreign keys defined? Are there foreign keys out there that seem obvious but are not actually enforced? Should they be enforced? Some of them not, because a lot of times there are tables that get dropped and reloaded, and reasserting those is not something that you can cheaply do on a daily basis. So maybe just document the fact that there is an implied relationship here, but you can't enforce it. This gets especially true when you're dealing with like Redshift and other databases that you can say there's a foreign key there, but it doesn't enforce anything. The last thing to think about with foreign keys is that when you have that relationship between tables, that sort of extends the privacy blast radius of like data in one table now touching into another, where like you had an address table, but now you have a customer table. The joining of those two makes, you know, things in extended tables from there also potentially personally identifiable. So that's a thing that you have to consider as well. Then you get outside the actual Postgres or whatever database you're using. Your data has inputs. It could be data entry. It could be flat files from a third party. It could be event logs. It could be, you know, logs that you've internally generated. Figure out whether you're responsible for those or not. If you are, then you have obligations. If not, then someone has an obligation to you. They have an SLA to meet with you, and hold them to that. Find out if that particular source can be paused. Is this data that we are fetching in when it is convenient to us, or is it data that they connect and they insert when it happens or when it's convenient to them? What do they do when they can't connect? Understand that. This again speaks to the maintenance window, but have an answer for each of these things and know which things can be shut off. Likewise, is that data, does it have some sort of privacy sensitivity, and are they addressing that? The next thing comes up is your data lifecycle. When the data comes in, it's probably really important, and then some of that data is important forever, but some isn't. I did a lot of work in ad tech, and the ad visibility that happened in the last day was of critical importance. And like how well ads did on the web in the last week was extremely important. And then once a quarter, people would care about the month-end results, and nobody cared about what happened the quarter before that. So it had a very Zipfian decline in how the data was important to them. And that gives you ideas about how to manage this. The data that's really important may need to have partial indexes on it that make that data more accessible. It may need to be in its own partition, and then you slowly age off partitions. When the data starts to lose importance, do you need to get rid of it? Do you need to anonymize it? What is necessary with this data for your situation? If it's just dead data, then it's taking up space in your tables, it's slowing down your vacuums, it's slowing down your index creations, it's bloating your indexes. You want to get it out of there if you can. So figure out the contours of that situation for, you know, all of your data, and have a documented lifecycle plan for that. Partitioning is a wonderful way to do that if one of the accepted partitioning regimens works for you, which basically means that there has to be some sort of expiry date or a created date that happens when the data first comes into the system, so it can live in that partition and not have to migrate too many times before you drop it. But obviously dropping partitions is a whole lot faster than deleting rows. Security, this is a tough one, and this is where you get a lot of pushback from the application developers. Find out how many roles exist in your system. How many different types of people do we think are connecting to these things? Check to see if each app has its own role. Spoiler alert, they don't. Does that role follow the principle of least privilege, which is to say, does it have the ability to do everything it needs to do and nothing else? And conversely, if it's the only person who needs to do that, does anybody else have the permission to do that? And if so, why? Thank you. I am a very strong advocate of having two types of roles in the system. You will, in Postgres land, you will hear people talking about users and roles interchangeably. And technically, all a user is a role that can log in. And I like to have policy-specific roles tailored perfectly to the applications that are needed. And then you have login-specific roles tailored to the people and applications that need to connect. And they have their own credentials that can be rotated as needed, often, if possible. But when you're creating the new login roles, you don't have to say it can update this table, it can see this table except for this column. All of that has been sorted out. You just say you can grant access from one role to another. So user Dave can see application customer orders. It's a very much simpler way to do things and much more sane when you're setting up policies. When you do get credential cycling in place, make sure that people are testing it often. So the sad reality is that most of these things were built with ORMs. The ORMs have one user that is a super user that can change tables, can create them, delete them, and that is the same user that is being used by the website code to do regular customer logins. And it's dangerous, and it makes query tuning hard because when you have a slow query, you look in the logs and all you see is this gobbledygook of select from schema.table.column, schema.table.column2, and so on. And you barely get to the from clause before that string is truncated. And then once you have that, you can't go grepping for it because no human wrote this. The ORM wrote it. So you have to hope that you can see enough of the from clause to guess which application was touching it. Even if you're using ORMs and they have their own user, the PGStat activity has the username in it. You can see that and you know which application to blame. That's great. But they don't do that because they like easy migrations and the convenience of them. So they have one user. They don't have to think about granting stuff when they create new objects. And you need to break them of that. Unfortunately, the ORMs are very poorly positioned to be able to handle that sort of thing. Your failover. Do you have a replica? Have you tried failing over to it? Can you use, if you needed to, if your replica went away, can all of your workload be done by one machine even for a little while? It's okay if it's in a degraded state, but just know when you can and know how degraded it will be. Last things to check, the network. Does the host name of your database server appear anywhere in your code? Stop that, get a DNS entry, make them connect with that. That allows you to shift to replicas quickly. That allows you to make other network operation changes as needed. Don't have that forced coupling. And then test that failover. With your downstream apps, ask, is this app read-only? Can it be put on the replica? What does this app do when it cannot connect? Same with all the others. And can we pause this? Can we stop them consuming this thing? With the reports, often they're going to some sort of a landing zone, an S3 bucket or something. Find out where they land, how long they stay there, whether that report has PII in it, because that's a problem we've discussed plenty. If so, are there access controls on that bucket? A lot of hacking attempts right now aren't even going after data servers. They're just going after the S3 buckets because permissions on them are usually excessively permissive. Do you have privacy controls in place? And do you have an expiry policy for those reports? For the data warehouse, does your data warehouse happen in a separate database? Is it happening just on the replica here and you're using the same tables? Do you have like a mini ETL going on that creates a little mini data warehouse and you're reading from that? Increasingly, the answer there is no, because people tend to like to use things like BigQuery and Snowflake and stuff like that. There's two ways they can go about that. They can take snapshots of your database and then upload tables wholesale, which is pretty common, especially with tools like dbt, which don't want to think about incremental changes to tables. On top of that, because things like Snowflake and BigQuery are not very good at incremental changes to tables. They don't have concepts like uniqueness and stuff like that easily enforceable. The other way is change data capture, where you're monitoring the change logs from your database and then moving just that data up. That is much, much faster, but it's also riskier that you're creating a synchronization issue between the data warehouse and yourself, and there's a source of truth issue going on there. And then what gets lost in translation between those two things? That's all I could think of, and I'm sure there's a few other things. Thank you all for making it to the conference and coming to my home city, and hope you have a good night. Any questions?
That was incredibly thorough, thank you.
Thank you. All right. Take care.